Now let us have Fourier transform of some standard functions. So out of that, let us have first one as Fourier transform of signum function. This is a typical one, so that's why I'm taking. Now how signal function is looking like, that is signum function states signum of t that is equal to 1 over the period 0 to infinity, and it is equal to minus 1 in the negative half, that is t minus infinity to 0. So standard signum function is this unit step as if in the positive half, and inverse of unit step in the negative half, or rather it is u of minus t minus of u of minus t. So this is in the negative half. So for finding Fourier transform, instead of taking it only 1 or minus 1 directly, one of the technique is, as considering limiting conditions, this signum function is redefined with the help of exponential function as limit as a tends to 0 e raised to minus at. This is e raised to minus at into u of t, and this is minus of, because this is minus 1, therefore this is minus, and this particular is denoted as e raised to minus a minus t multiplied by u of minus t. So you can see how it looks like. So this is decaying exponential and this is rising exponential, but from minus infinity towards minus infinity, as from y-axis to x-axis transition, and it is denoted as minus e raised to minus a minus t, a into minus t and u of minus t. So this is now becoming appropriately transformable. Otherwise, from minus infinity to plus infinity, if we substitute a limit considering this condition, that it is equal to 1 for 0 to infinity and this is equal to minus 1 for minus infinity to 0, this will be very difficult to integrate, and that will not be treated as a transformable form, uh, valid form as far as mathematical operation is considered. So for this reason, we have approximated it into exponential with the help of exponential function. And now we will solve for Fourier transform, that is limit a tends to 0 e raised to minus a t u of t minus e raised to a t u of minus t. Fourier transform of e raised to minus a t u of t, we know that 1 upon a plus j omega. Fourier transform of e raised to a t into u of minus t is 1 upon a minus j omega. So these two Fourier transforms we know, that is e raised to minus at ut is 1 upon a plus j omega. E raised to plus at u of minus t is 1 upon a minus j omega. And therefore, if we substitute this for first term 1 upon a plus j omega, for the second term 1 upon a minus j omega, and therefore limit as a tends to 0, Fourier transform comes out to be 2 upon omega. Magnitude is 2 upon omega. And as far as phase is considered, it is imaginary coefficient divided by real part coefficient. So here we have written this as 2j by omega, and divided by, here we are taking only magnitude, so that's why we have written 2 by omega, and this is minus pi by 2 to plus pi by 2. So this will be looking like the phase spectrum and magnitude spectrum. Now we will have one more function. This is also one standard function. This is of this style, that is, it is a pulsating function from minus tau to 0 and 0 to tau, and the amplitude is a from for negative half and minus a for positive half, exactly reverse. So how it is looking like, m of t is equal to a for t minus tau to 0, and it is equal to minus a for t 0 to tau. This is typical. Sometimes in question paper you will have here some other number as a tau as well as a, but the style for solving this is same. See here how to do. Now f of omega is f of m of t. M of t, what is the basic definition of Fourier transform that we are applying? That is integration minus infinity to infinity, ideally m of t into e raised to minus j omega t dt. Now this will be minus tau to 0 a into e raised to minus j omega t dt, and plus 0 to tau minus a into e raised to minus j omega t dt. Now integration, a is a constant, integration e raised to minus j omega t dt will be e raised to minus j omega t divided by j omega minus j omega. over the interval minus tau to 0, and this will be same minus a. I have taken it outside a, and e raised to minus j omega t divided by j omega, and this is minus sign. So this minus sign and this minus sign, it is made plus. So plus a into e raised to minus j omega t divided by j omega over the period 0 to tau. Now it is a upon j omega, and into bracket we have taken j omega common. Here we have given this minus sign. So e raised to 0 upper limit, that is 1. Middle sign is minus. So this is also minus, minus minus plus e raised to j omega tau. T we are putting minus tau. So minus minus plus, and that's why j omega tau plus a into e raised to minus j omega tau upper limit, and lower limit is 0. So that is middle sign is minus e raised to 0, that is 1. And therefore this comes out to be minus 1 minus 1 minus 2, and this is if we little bit simplify, e raised to j theta plus e raised to minus j theta divided by 2 we want. So we are doing multiply by 2 and divide by 2. So multiply by 2 is kept aside, and e raised to j omega tau plus e raised to minus j omega tau divided by 2. This gives you a cos function, Euler's relation, e raised to j theta plus e raised to minus j theta divided by 2. So therefore this is cos of theta, that is omega tau, and outside is this minus 2 taken outside, minus 1. So minus minus, that is becoming plus, plus 2a by j omega, and inside 2ja by omega into bracket 1 minus this minus sign we have given outside and change the sign, and it is coming out to be cos of omega tau. So we can make it as cos in terms of sine square as per our identity. 1 minus cos theta is equal to sine square theta. So or 2 sine square x is equal to 1 minus cos 2x. So accordingly we can change this, and we can interpret it in this particular form, or otherwise you can keep it as it is. So the way you want, you can keep it, no problem. Just see here, if you want to simplify it in this term, sine square function using this identity 1 minus cos 2x. So that way you can keep like this or change this. Accordingly you will get. Done.